Hi and welcome. I'm trying to learn biochemistry. Today, solutions, colloids and suspensions. And after we've done that, we're going to do shoulder impingement chaining. And if you participate in a shoulder impingement chaining, then it's at your own risk. And this is part 3, I think, of solutions, colloids and suspensions. And now we're trying to go over what we learned and try to present it. Now the first thing are the solutions. We're trying now to gather the informations together which we have our solutions and then to prepare the presentation of them. Now the first thing, a mixture is a combination of elements or compounds that are physically blended together but not bound by chemical bonds. For example, the air a human is breathing in is a mixture of gases, mainly nitrogen, oxygen and argon. 3 common liquid mixtures are solutions, colloids and suspensions. So have a look at that sentence. Here is said that solutions, colloids and suspensions are all mixtures. So they don't have fused together, bound together and become new chemical elements. They are just mixtures. They are physically blended together but not have formed chemical bonds. Now, the first thing here is that are the solutions. In a solution, a substance called the solvent dissolves another substance called the solute. I don't think it is wrong, but I prefer it very much to say the other way around. A solute is dissolving in a solvent. Usually there is more, I assume it is right, so I'm going with it. Usually there is more solvent than solute in a solution. You don't have to say that. For example, a human's sweat is a dilute solution of water. And water is the solvent, and a small amount of salts. These are the solutes. The water is dissolving the salts. The salts are dissolving in the water. Is that the difference? I don't think so. Once mixed together, solutes remain evenly dispersed among the solvent molecules. Because the solute particles in a solution are very small, the solution looks clear and transparent. Okay, a solution where a solute is dissolving in a solvent, for example, salt and sweat. And these solutes, this salt which has dissolved in the water, stays evenly dispersed through it. Evenly dispersed. And also is the solution clear and transparent. Let's give it away. I'm not sure if that is true. Is the solution clear and transparent always? Now the question is, do we have to edit that place now? What would be the difference to colloids and suspensions? Or is it enough to explain that it are solutions? A colloid differs from a solution mainly on the basis of the size of its particles. The solute particles in a colloid are large enough to scatter light, just as water droplets in fog scatter light from a car's headlight beams. For this reason, colloids usually look translucent or opaque. Milk is an example of a liquid that is both a colloid and a solution. The large milk proteins make it a colloid, whereas calcium salts, milk sugar, lactose, and other small particles are in solution. In both solutions and colloids, the solutes do not settle out and accumulate on the bottom of the container. Yes, okay, we're going to edit. It's transparent. It's clear and transparent. In a colloid, there are larger particles in it, which are too big to break larger particles in it. In a suspension, by contrast, the suspended materials may mix with the liquid or suspended medium for some time, but eventually it will settle out. Okay. And in a suspension, they could be mixed, but they would then over time sink down to the bottom, for example. Okay, I think we have it together. I'm going to start this in camera. Okay, solutions. Solutions are mixtures. Mixtures. Why don't we just make what mixtures are? By a mixture where different things, different elements, different substances are mixed together. They are physically blended together, but they are not bound chemically together. Air, for example, consists out of nitrogen, but it's not understandable for people, they can't see it. So we're having here, for example, we could say milk with the milk proteins, or we could say what was the other thing? Sweat. Sweat is a good example. Is it? We're going without an example. Okay. Let's try it. If it works without an example, that's good. It's a bit difficult. What do I want to explain when? I want one for solutions, one for colloids, one for suspension, all three. I want one for mixtures, but do I then say that the other three, I'd explain them directly, and I want one for all three? One video, one presentation. Let's say just what is the mixture. That is good. We don't need more information. Mixtures. A mixture are different types of substances, whatever, physically blended together, but they did not have found new chemical bonds. For example, sweat, that is water and salts, they have mixed together, they are physically blended together, but they did not form a new chemical bond. That is according to Gerhard Torres and Sandra Lebowski's Principles of Anatomy and Physiology book, page 38, which is non-medical advice. I don't know what's important to say that here. I'm going to stop the camera and now we're going to go through the solutions. Okay, solutions. It doesn't really make sense to explain solutions without saying what colloids and suspensions are. But if I say what is the use of having a video just individually for solutions? Evenly dispersed, this is important. And clear and transparent. Solutions. By solutions there are... Okay, I haven't prepared the sentence. Solutions. By solutions there is a solute dissolved in a... What was it? In a solvent. Solutions. By solutions, there's a solute dissolved in a solvent. Solute, solvent. Solutions. By solutions, there is a solute dissolved in a solvent. So, for example, sweat. The solute salt is dissolved in the solvent, the water. And important for solutions is that the solute, the salt, is evenly dispersed among the solvent, the water. And they are also clear and transparent. By colloids, where, for example, milk is a colloid and a solution, there are some smaller particles, they are then a solution, but the bigger milk proteins, they are now a colloid because they're bigger and they're breaking the light, so they have not completely mixed with it. They are not clear and transparent. Colloids, solutions are clear and transparent, and the solute, the salt in the sweat, is evenly dispersed, and it stays also like that in compositon. This is in my head, compositon. Suspensions. I don't know, it is a bit too much explained. But if I get it short and good. Solutions. In a solution, there is the solute dissolved in the solvent. For example, in sweat, there's the solute salt dissolved in the solutions in the solvent. Solutions. By solutions, there is the solute, for example, salt dissolved in the solvent, the water. And important for solutions is that they are evenly dispersed. So the solute is evenly dispersed in the solvent. The salt in the sweat is evenly dispersed in the water, and they are also clear and transparent. Colloids is something else. but similar where they are too big. For example, in milk, the milk proteins are too big, they are not transparent, milk is not clear, and therefore it is a colloid. And there are also suspensions where it would happen that they sink down for some time, over some time. Blood, for example, is a suspension. The hemoglobin cells would sink down over some time. In a solution, they don't sink down, they are evenly dispersed and stay evenly dispersed, and it is also clear and transparent, so like sweat. It is the solute salt dissolved in the solvent water, a solution. And that is according to Gerard Tatoga and Sandra Grabowski's Principles of Anatomy and Physiology book, page 38. But this is no medical advice. Okay, now I'm going to set the camera. And right, for the biochemistry part. In the next part, we're going to do a video about the colloids, and one about the suspensions, and then about all three. But for now, we don't have time left. We're going to do the other thing. So, if you were here for biochemistry, you can go directly to the next part of biochemistry. If you stay here and participate in the shoulder impingement training, then it's better hours. Good and stable stance, and doing shoulder circuits. Go back, up, front, and down, back, and down, again and front, back, down, and front. Now with long arms and strong fists, go far back with the shoulders. Right up, right, down, again back, up, and front, down, up, back, down, front, up, and down. And now, have the legs standing, put and stable. Long arms with strong fists, bring the shoulders down and together. And turn the arms with the fists to the inside. So fists down, together, the arms to the inside. Arms to the outside, shoulders down and together. Arms to the inside, shoulders down and together. Last time, arms to the outside, shoulders down and together. And now the arms up, a bit in front, the fists again, the arms in front, shoulders down and together. Arms back, shoulders up and in front. Arms in front, shoulders down and together. Arms back, shoulders up and in front. And now, lift the arms up and shrug the shoulders up and let it roll down again. If this causes pain, then don't do it. The arms up, shoulders up, and roll down. One more time, arms up, and roll down. Arms together, down into the outside. And now, with sundial, you can use a sock or a t-shirt or something else. Have it with a long arm at the outside, let it fall down and try to catch it again. And on the other side. And now we're stretching the elephant trunk. One arm in front, the shoulders back, down, pull the arm in, have flat fingers, try to relax the arm, go a bit back with the shoulder until the palm up to the sky. And the other arm in front. Shoulders back and down, pull the arm and have flat fingers, try to relax the arm, go back with the shoulder until the palm up to the sky. And that was your short impingement training. I thank you very much, and until next time.